And hello everyone, my name is Nurnazifa Irdina binti Yusmi. I'm a first year student in School of Physics majoring in Pure Physics. I will be the presenter for this video.
Assalamualaikum and hi, my name is Hana Birrah binti Zaini, first year student from School of Physics majoring in Geophysics, and my role in this assignment is as Raiduan.
Hi, I'm Nurnazifa Syazwana bin Raiduan, batch number 159398. I'm first year student from School of Education, major in Physics. I am editor in this school.
So, as you can see from the previous video, we know that iPad is also one of the devices that use LiDAR. What exactly is LiDAR? LiDAR in certain aspects more like radar. Like radar, it is an acronym and short for light detection and ranging. Let me share with you a little history about LiDAR. LiDAR was first used in the 1960s when laser scanners were mounted to aeroplanes. Apparently, LiDAR didn't get the popularity it deserved until 20 years later, which is pretty absurd. LiDAR technology is the application of remote sensing method. It is usually used to examine the surface of the earth, access information about the ground surface, create a digital twin of an object, or detail a range of geospatial information. LiDAR technology is broadly categorized based on its functionality, which is into two types. The first one will have the airborne LiDAR. The second one will be the terrestrial LiDAR. Now, aren't you curious about how it works? Yes? Then let's get into it. So, systems that use LiDAR will send out the pulses of light just outside the visible spectrum and measure how long it takes for each pulse to return. Whenever the pulse reaches some object, data points are collected regarding its direction and distance from LiDAR. Using LiDAR sensors, one can determine the shape and orientation of any object in space based on the time difference between the emission of a laser signal and its return to the sensor after bouncing off. With repeated pings, a device with LiDAR can also learn how nearby objects move, their speed, and also whether they are facing toward or away from the LiDAR device. There are three main components of any LiDAR device: a laser, a scanner, and a specialized GPS receiver. The LiDAR instruments emits rapid laser signals, sometimes up to 150,000 pulses per second. Although every device works differently, but generally they send out beams by sweeping in a circle like a radar dish, while also moving a laser up and down. Here's a process that every LiDAR device follows. First, a laser emits signals. Then, a signal reaches an obstacle. A signal reflects off the obstacle. Next, signals return to the receiver. Last, the laser pulses are registered. Each registered pulse is assigned a location and representation in a LiDAR point cloud. In most cases, a point cloud works as a middleman between the raw data collected by the LiDAR processors and 3D models. Yet, clouds can be used to store any spatial information and manipulate it for various algorithms, artificial intelligence, machine learning, and any other software analysis. For instance, a LiDAR mapping program can georeference each point in a point cloud to create highly detailed maps of real-world environments. So, as we know, every technology has its pros and cons. So is LiDAR. LiDAR technology offers incredibly accurate and consistent results. The short wavelength can even detect small objects and create exact 3D models, making it possible to determine what the objects are. Next, LiDAR sensor sends out laser pulses and receives them back in nanoseconds, making it possible to scan large areas in a fairly short period of time and still get a high volume of data. LiDAR is also a versatile technology. It is compatible with other surveying methods and imaging techniques. It is also can be used alongside sonar or radar systems to address its limitations and complement one another. Throughout all the advantages, it still has its drawbacks. One of the disadvantages is LiDAR technology does not work well in areas where there are high sun angles or huge reflection. This is because the laser pulses depend on the principle of reflection. Next, LiDAR has a very large data sets that are difficult to interpret. For this reason, it may take a lot of time to analyze the data. Lastly, there are elevation errors due to inability to penetrate very dense forests. In some instances where the canopies over the forests are very dense, the LiDAR pulses may not be able to penetrate the canopies, thus returning the incomplete data. As a conclusion, LiDAR is a remote sensing method that uses ultraviolet visible or near-infrared sources such as laser to measure the distance of object with accuracy, precision, and flexibility. The four parts of LiDAR system, which are LiDAR sensor, GPS receivers, initial measurement units, and computers, work together to produce highly accurate results. This ranging device also has advantages and disadvantages. However, the use of LiDAR can ease our daily activities, especially in this technology era. For example, robotics, luggage handling, and self-driving car. That's all from us. Thank you everyone.